Hello everyone, this is Mr. Mohammed Hussein from Al Noor International School, grade 10 geometry teacher. Welcome to week 13, chapter 12, lesson 2, chords and arcs. Here are the objectives of the lessons: to use congruent chords, arcs and central angles, to use perpendicular bisector to chords, a segment whose endpoints are on a circle is called a chord. A segment whose endpoints are on a circle is called a chord. The diagram shows related chord and arc is shown below. Look at this circle. Point A, B, C, D are on the circle. So AC is a chord of this circle, and we have the major and the minor arcs of this circle, as you have learned it before. Major arc is ABC. This bigger arc is the major arc of this circle, and ADC or CDA is the minor arc of the circle. So keep in your mind, AC is a chord or a segment whose endpoints are on a circle. That means at these two endpoints. Now let's see some important concepts of this lesson or terms. Concept 1: within a circle or congruent circles. Number 1, congruent central angles have congruent chords. Congruent chords have congruent arcs, and congruent arcs have congruent central angles. Look at this circle. The central angle O are congruent to each other. This means this angle is congruent to this angle. So congruent central angles have congruent chords means we have chord DC and the chord AB. If the central angles are congruent, so the chords of those angles are congruent to each other, which means DC is congruent to AB. And congruent chords have congruent arcs. If DC is congruent to AB, so the arc DC is also congruent to arc AB. Since chord DC is congruent to chord AB, so the arc DC is congruent to arc AB. Congruent arcs have congruent central angles, which means if this arc DC is congruent to arc AB, that means the central angle AOB is congruent to DOC. Or in other words, if angle DOC, for the first statement, if angle DOC is congruent to angle AOB, angle OAB, then DC is congruent to or equal to AB. You see, this chord is congruent to this chord. For statement number 2, congruent chords have congruent arcs. If DC is congruent to AB, then the central angles are congruent to each other. Conversely, if arc DC is congruent to arc AB, this arc is congruent to this arc, then the central angles are congruent, which means angle AOB is congruent to angle DOC. Concept number 2: within a circle or congruent circles, chords equidistant from the center are congruent. Chords equidistant from the center are congruent. What means equidistant? having the same distance from the center. Equidistance means equal distance. Congruent chords are equidistant from the center. Conversely, congruent chords are equidistant from the center. Conversely, look at this figure. In this circle, we have chord DC and AB. CD and AB are chords. As it is shown from this graph, EO is congruent to FO, which means these two distance, FO is congruent to EO. That means CD is equidistant from the center as AB, since the distance from O to F and O to E are the same. So if EO is equal to or congruent to FO, then DC is congruent to AB. If EO is congruent to FO, then DC is congruent to AB. If DC is congruent to AB, if DC is congruent to AB, then EO is congruent to FO. Conversely, this is the converse of the first one. Concept number 3. In a circle, a diameter that is perpendicular to a chord bisects the chord and its arcs. In a circle, a diameter that is perpendicular to a chord bisects the chord and its arcs. Number 2, in a circle, a diameter that bisects a chord that's not a diameter is perpendicular to the chord. In a circle, a diameter that bisects a chord that's not a diameter is perpendicular to the chord. Number 3, in a circle, the perpendicular bisector of a chord contains the center of the circle. So here we have 3 concepts. Look at this figure. In a circle, a diameter that's perpendicular to a chord bisects the chord and its arcs means, look at FB and AC. Since O is the center of the circle, AC and BF are the diameter and passing through the center. But when AC passing through the center, what will happen to chord BD? It is bisected by AC and at the same time it's perpendicular. It makes 90 degrees here. And further, AC bisects the chord BD. As it bisects chord BD, it bisects chord BC. Again, from this side, if you take the diameter FB passing through the center, it bisects chord AE. At the same time, it bisects arc AE. Let's see some examples. Problem number 1, using chords. In the diagram, circle O is congruent to circle P, given that AB is congruent to DC. Then what can you conclude about these graphs? Here are the circles. We have 2 circles. AB is congruent to DC. AB is congruent to DC. That means the chords of these circles. Circle 1 or circle O is congruent to the chord DC of circle 2 or circle P. Then what else can you conclude about this fact? We said chords, if the chords of one circle is congruent to the chord of the other circle, then their central angles must be congruent to each other. which means within congruent circles, congruent chords have congruent central angles. So arc AB is congruent to or congruent with arc DC. Since AB is congruent to DC, this arc DC is also congruent to this arc AB. At the same time, this angle must be congruent to this angle. Problem number 2, finding the length of a chord. What is the length of AB in a circle O? Here is a graph. What is the length of AB in a circle O? AB means it's a chord in this circle, this one. What are the givens? DC is 8 centimeter, but this is congruent to CB, and O is the center of the circle, which is 5 centimeter from AB, and again 5 centimeter from DB. So how can I find the length of AB when DC is given in this situation? We know that if chords are equidistant from the center, then they are congruent. Since the distance from AB to the center is 5 centimeter, and again the distance from chord DB to the center is 5 centimeter, that means they are equidistant. Chord AB and DC are equidistant from the center, which means AB is congruent to DC. Then what is the distance of or the length of DB? It is 16, because this is congruent to this one, this is 8, this is also 8, which means DC is equals to BC, 8 centimeter given. DC plus BC, which means 8 plus 8 is equal to 16. So AB is equal to DC as it is equidistant from the center. Example number 3, finding measures in a circle. What is the value of each variable to the nearest edge? Here is the situation in this circle. AD is 8 centimeter, BC is 3 centimeter, and AB is x. So how can I find x? Remember, the diameter which is passing through the center, if you extend this as a diameter, the diameter passing through the center, as B is the center of the circle, bisects the chord and it's perpendicular. At the same time, it can bisect the arc of that chord. So since the length AB is 8 centimeter, what can you say about this length AC? It will be 4. It will be 4, and this also 4. So look at this triangle. It's right angle triangle. We have 3 and 4. The legs are 3 and 4, and the hypotenuse is x. So you can use Pythagorean theorem to solve for x. AC is half of AD. AC is half of AD, that is 4. So x squared is equals to 4 squared plus e squared. X squared is equals to 25. Just taking the square root of 25, x will be 5 centimeter. Example number 3, part B. Find the value of y when O is the center point. Here is the graph, and how can you find the value of y? Look at the givens. AB is 12, BC is also 12, DO is 13 centimeter, but how can you find BO or Y? Remember, the diameter which is passing through the center, which means if you carefully draw the diameter, this is the diameter passing through the center, at the same time bisecting AC, because this is 12, this is 12. Then this diameter is perpendicular to this chord from the previous concepts. When the diameter passing through the center bisects the given chord, it's also perpendicular to that chord, which means this angle is also 90. This angle is also 90. So looking at triangle ABO, triangle ABO is right angle triangle. But how do you know the length of AO? AO is the radius of the circle as DO. So AO is the same as 13. It is 13 because DO and AO are the radius of the circle. So if this is 13, this must be 13. Then, using the right angle triangle ABO, you can use Pythagorean theorem, which means the legs are y and 12 and the hypotenuse is 13. So 12 squared plus y squared is equals to 13 squared. If O is the center, then BO is perpendicular, bisector of a chord. The diameter through the center perpendicular to and bisect the chord, of course. ABO is right angle triangle with angle B is 90 as this diameter perpendicular bisector. AO is equals to DO, as I said it. It's the radius of the circle. So using Pythagorean theorem, 12 squared plus y squared is equals 13 squared. Then solving here, that means y squared is equals to 169 minus 144, taking 144 to the other side, and y squared is equals 25, and taking the square root of 25, y is equals to 5. And finally, I would like to say thank you for watching this video, and dear students, as usual, do not forget to practice questions or exercises from your textbook and workbook related to this lesson. Have a nice time.